Teacher asks a question, kid gives an answer, the teacher says, right, you're right. They have no clue whether the kid knows anything about why that's the answer. They had a 50-50 chance, for God's sakes, right? The second way that we hide decisions is we ask a question. When they get it wrong, then we ask them a question. I want to know, why the hell did they pick 6? I want to know that. I don't want to know if they know the 6 go into 3. That doesn't help me. It doesn't help them either. The other way is we talk about what we did without any why. So let's construct a rectangle. Segment, I'm going to do a perpendicular, then another perpendicular, and then I'm going to put a point on one of the perpendiculars, just wherever, and then I'm going to draw another perpendicular, and then I'm going to make an intersection, I'm going to hide a bunch of stuff, I'm going to make it really pretty. Right? And you all agree that I've ended up with a rectangle, and you all agree, yeah, that all sounds big. I didn't say anything about why I did any of those things. What were the decisions behind them? I didn't tie the construction steps to the properties of a rectangle. Just gone. Right? Here's another example. In what is considered a classic textbook, if you recognize it, you're probably fairly old. And this is my grandmother's desk copy from 1967. So here's this problem, like you travel here and you come back, and how long did it take? Well, here's how you set it up. Right? We define this variable, and then this one, and then there are all these things that are important. Oh, and there's a cute picture. And then we make this table. And to the kids, that all makes sense because it's happening in front of them, but they don't know why those things were done. So when they're asked to do it, they don't know how to get started because we didn't make the decisions explicit. A favorite of mine, the kid comes up, slaps his stuff onto the document camera, and proceeds to read it to us, right? I know what you did. I do not know why you did them. I want to hear why you did those things. If you have kids reading things at the document camera, shame on you. Here's a curriculum where here's another distance rate time problem. We want to answer something, so let's fill out a table. No, let's talk about where the table came from. Why did you decide on those columns? How did you decide to organize it that way? Why is that important? That's the important part, and that's the part that's getting hidden from the kids. Let's talk about x is greater than 5 and how to graph it in 5th grade. You just do these 3 things. Well, there's a lot of hidden stuff here. Why are we using a number line? Why does it go from 0 to 10? Why are some of the things open circles and some of them are closed circles? And then how come we only colored in some of them? And then what the hell's with the arrow on the end, right? All of this is hidden from kids. They just think these are the things you do, and if I memorize them, I'll be good to go. Right? So in a 1st grade class I worked in one day, so we're doing in-out tables, and the teacher says, well, the numbers going out are smaller than the numbers coming in. What does that tell us about the sign? And I said, no, don't ask them about the sign. Say, the numbers are this way, so what? And then I thought, I'm still pointing out about the numbers. Let the kids figure that out. It's important that you would look at the numbers and see how they work. In a 10th grade warm-up, geometric probability, what are the odds of hitting the bullseye? Before the teacher even asked the question, she wrote this on the board. I think it's important that some kid come up with, why would we start like that? That's really important. She made a decision and didn't talk about it. In the same class, she asked, well, how many ways can we arrange 4 things? And some kid says, oh, there are 4 slots. And so she proceeds to write this on the board. That's not 4 slots, that's 4 very particular slots for something, and no one talked about why. In the same classroom, put this in your calculator, they finally figured out we needed it in y equals form. Some kid says divide, and the teacher asks divide both sides by what? I mean, the kid didn't say anything about both sides. You're making these decisions for them. Let them do the thinking. So, we have this standard for mathematical practice that's about constructing viable arguments and critiquing the reasoning of others. If we never hear that reasoning, how can we critique it? Right? We need to make sure that that is more important in our classrooms than the answers. So what do? Don't ever say right when a kid gives an answer. Please, please, please. Ask them, how did you know? How did you decide? Make sure what is always accompanied by why. Let the students make as many decisions as possible. Do not state the obvious because it may not be obvious to everybody else in the room. Right? Pay attention. Look for decisions you make your kids could make instead. Notice moments when the kids don't say why and you didn't ask them. Try a couple more times a period to ask them to do why and be conscious of explaining your own decisions. Let's practice. I constructed the perpendicular because a rectangle has right angles. The answer is 6.
How do you know?
Very